Now, again, I'm only going to hit the highlights. I'm not going to hit stuff that I think is irrelevant. Make sure you can graph on your graphing calculator these functions, but they are also in your family of graphs, and that is the cubic function, the fraction, the rational, okay, and the root. So let's go ahead and there's the rational function. What is a rational? It's a what? A fraction. Now remember, when is the domain affected? In a radical or a what? Rational. The domain here is going to be affected because what can you not have in the denominator? I don't understand the word he just said.
A zero.
A zero. Zero cannot be in the denominator. So therefore, if a number gives you zero in the denominator, the function blows up, or you have what's called a vertical asymptote. And we'll get there eventually. And of course, here is the base function. Look on your family of graphs. Everybody get your family of graphs out. 1 over x, remember, is a half a volcano. What does a half volcano mean? That's a half of a volcano. Here's the half right here. And then the mirror image is across the origin. So make sure you know a rational function. This is in your family of graphs. I told you it's very important. The vertical asymptote, in this case, 1 over x, is the y-axis. Write that down. The y-axis is your vertical asymptote. Vertical asymptote is, remember me telling you in calculus, the limit theory, take a step toward the wall, and each step after that you take half the previous step. Will you ever reach the wall? No. That line never reaches, that blue line never reaches the y-axis. This is where you start to get into limit theory. Limit theory is your first section of calculus, because algebra and limit theory put together is calculus. So, there is what you need to know right there. Now, what if you have 1 over x plus 2? Well, the plus 2 is within the function, so that means it's a horizontal shift of 2 to the what? Left. What if you have 1 over x, and then you have parentheses plus 6? Well, if the plus 6 is beside the function, then you know it's what? A vertical shift, which means 6 what? Up. So you got to be looking for those things. So this is test material right here. Make sure you know what this function looks like. And make sure you can graph it on your graphic calculator. So negative 2 over x. Well, negative 2 over x, you rewrite it. This is exactly what I'm talking about with, you should know this material from being in Unit 1 and Chapter 3. You draw the parent graph. The parent graph looks like what? Looks like that. Okay, there's the parent graph. This is negative 2 times 1 over x. So let's talk about what we know. F of x is equal to, well, we've got, I'm going to rewrite this. F of x is equal to negative 2 times 1 over x plus 0 plus 0. Now what I've just done is I've put it in the form that we've been studying for the last 2 chapters. So what is my vertical shift? 0. I'm horizontal shift. What is my vertical shift?
0.
So what's the only thing that changes? Well, I'm going to take my handy dandy highlighter and I'm going to highlight that guy. And then I'm going to highlight this guy. So what does the negative tell us? It goes the opposite direction. So now the volcano is going to be on this side and over here. And what does the 2 tell us? It's going to be what? It's going to be compressed along the x-axis and stretched along the what? So it's not going to look like this. It's going to look a whole lot skinnier. So what happens if I was to push these 2 functions together like this? What would it look like?
There'd be less of a curve.
It'd be less of a curve. It'd be more like a corner, wouldn't it? If I push this in, what would that do? Or if I pulled it up this way, it's going to look more like this. Now graph it. Okay, I'll just do it on here. You don't have to graph it on your calculator. And you can't always tell exactly what it's going to do, but you just get an idea. And they write it 2 over 1 over x. There you go. And you can't really see it, but if you was to do 1 over x, you'd see a difference between the 2. Okay? Now, what is the vertical asymptote? Well, to find the vertical asymptote, and write this down and highlight it, and this is red, so that means it's very important. To find the vertical asymptote, I'm just going to write vertical asymptote. That's set denominator, and I'm going to put denominator slash radicand, because you're going to see that in the future, equal to what? Because you can't have 0 in the denominator, and you can't have a negative under a even root. And that's where the 2 are affected. That's where the domain is affected. So, x is equal to 0 means that if you put 0 in the denominator for x, you're going to get a vertical what? Asymptote, meaning that the function does not exist on that red line right there. The function does not exist where x is equal to 0. X is equal to 0 is the y what? Axis.
So if you were going to do domain for this, it would be
Negative infinity to 0, 0, non-inclusive, because you can't touch 0. There's the domain. The range would be negative infinity to 0, and from 0 to what? Positive infinity. Now, there is a way to find the horizontal asymptote. We will get to that eventually. And it has to do with the degree of the denominator and the degree of the numerator. This one is 0 because you have a constant, -2, and we'll get to that. So, do this one. Now we know, I don't want you to graph it on a calculator, I want you to sketch it. Do me a favor. Take this down to the, you know what the computer lab is?
Nope.
It's right there in the front.
Oh, that one.
Okay, there's a lady in there that's sitting in the desk, in a little office there. In the computer lab, tell her that that's from 137 and I need a battery, please. Thank you. All right, so I'm going to rewrite this. I'm going to say f of x, because this one's not exactly writing correctly, and this battery's okay. And now this one says, get 2 batteries. This one's going dead too. Yeah. All right. So I'm going to rewrite this. 2 parentheses 1 over what?
x plus 1. So
now, and we'll write plus 0 out here. Okay, so that means we've got a horizontal shift of 1 to the what? 1 to the left. And the vertical shift, it's supposed to let me write with, okay, I guess it's just not going to, supposed to let me write with my finger. Okay, I guess today is just, okay. And a horizontal shift of 0. I meant vertical shift. 0 horizontal shift. Find it. Thank you. Here, you can put that one in that one. I think you can handle it. Please don't let him screw it up. Look at these batteries. They look like they come from Amazon Basics. Oh, no. Great. Let's try that. See if that works better. Thank you, sir. Oh, green light. Green light. And I tell you what, critical thinking skills are out of this room. Look at there. Horizontal shift. What does this mean? In positive direction, which means it's a regular half volcano. Okay? What does this mean? It means it's pushed in, so it's going to be, instead of the vertical the horizontal shift is 1 to the left, so instead of the origin being here, it's going to be where? Right here, so I'm going to draw a new vertical asymptote right here, and I'm going to draw like that. Now, how do you know that's the vertical asymptote? Set the denominator equal to what? So x plus 1 is equal to 0. X cannot equal what? -1. That's your vertical asymptote. I remember when I was in algebra, I had a teacher that sucked. And I remember this section when I was taught. And I'm going to tell you something. It can be taught in an easy way, and it can be taught to lobotomize students. But if you build up with chapter 1, 2, and 3, you're used to seeing vertical and horizontal what? Shifts. So it should be like nothing to y'all. And you should really appreciate your algebra teacher.
Thank you.
You're welcome. Y'all suck. There it is. And now you go, okay, the domain is negative infinity to -1, exclusive, -1 to infinity. What's my range? From negative infinity to 0, 0 to what? Infinity. Is that a test question? Yes. So you've got 2 test questions in your notes. I'm not going to try to make this difficult, but I will give you a trinomial because that way you'll have to factor or use completing the square. So that's what it looks like. Same thing. Now, here the vertical asymptote, the horizontal asymptote is going to change, but I don't know if they want us to do that on this one. But first we rewrite dividing x plus 1 into x plus 2. Yep. Yep. Now, the other way to do it is to look at the, and we're going to do this test later. Go back one. Oops. When the degree of the numerator is the same as the degree of the denominator, basically it's going to be 1. What's 1x over 1x? 1. If it was 2x over x, it would be 2. The horizontal asymptote would be 2. We're going to get into that later. Right now they're telling you to divide. And when you divide, you get the horizontal asymptote is what? Not 0 anymore, but what? 1. Okay, so let's go through that. And I'm just going to go back to the original equation. And we're going to go through and do that. So, first of all, 1. Set denominator. Equal to 0. So x plus 1 is equal to 0. X is equal to -1. Therefore, x cannot equal -1 in this function. So that's your vertical asymptote. X is equal to -1 is your vertical asymptote. The horizontal asymptote, you look at the degrees, and this is for later, but right now they want you to divide. But for 2, for your horizontal asymptote, you're going to look at degree of denominator and numerator. Now that's for later, but right now you're going to divide. And when you divide x plus 1 into x plus 2, how many times will x go into x?
1.
1 time. 1 times x is 1x. 1 times 1 is what?
1.
And then you always subtract. And you get 1 remainder, but that doesn't matter because that is your horizontal asymptote. Now later on, you're not going to divide, you're just going to look at it. And we'll get into that later. So now, what kind of function do we have? We have a volcano, and it's going to have a volcano, and it's going to look like the graph, but you've got to realize that the vertical asymptote is -1, and your horizontal asymptote is 1. So it's going to be like that. And you should feel like, oh, I see this. I see this a whole lot better because we've been drilled horizontal everything in chapter 1 and chapter 2 and chapter 3. So you should feel okay here. You shouldn't feel like I have no idea what he's talking about. There it is. Now, again, the domain and the range is based on the vertical and the horizontal what? And again, most of you should have seen this in Algebra 2. You know, before they threw you into Math 120 and told you didn't need math your senior year. That bull crap. And they wonder why we don't have a lot of engineers. Okay, here's your full volcano. This is your second test type question that you're going to see on the test. 1 over x squared. You should have it in your family of graphs. It looks like the full volcano because you can't have a negative on this one. You can't have a negative product. If you plug in -1,000, you're going to get a positive BA number. So it's all going to go above the y-axis. So that's why you don't have a half volcano below. Now, if there's a negative in front of the function, the volcano turns into a funnel, right? And hopefully, or a vortex. If you want to call it a vortex, we'll call it a vortex. Depends on how nerdy you are. Okay?
I have a vote for funnel or vortex.
Let's call it the predator. All right. So how do you do this when you set the denominator equal to 0? To find your vertical and horizontal, you watch for the degrees. And we'll get into that later. So you should have this. You don't need to write it down because you got your family of graphs. It should be in there. Make sure you can graph it on the graphing calculator. The only thing I would suggest you do is put a parenthesis around the x squared, because no matter how much you worship your calculator, it does not think. So it may not do it correctly. Okay, let's look at this one. What's the horizontal shift? 1 to the what?
Right.
So that means that your your horizontal asymptote is +1.
Right.
And you should not even think about that. You should be like, oh, that's a horizontal shift. I got to move 1 to the right. Again, that's a test question, so write that down. So far, we've done 3 test questions. Now we're doing another 2 or 3. Here's one right there. Now, if you noticed, you're getting quadratics on the bottom. Is your shortcuts, is your reverse FOIL, is your complete the square going to come into play? Yes. So, and there's asymptotes are not part of the graph. You got imaginary, put them in there. Okay, now I want you to tell me what this one's doing.
Horizontal shift to.
Okay. Okay, I heard 2 to the left.
And down.
The rest I heard mumbles. What?
2 to the left, down.
I think I heard you say down 1, down 1, down 1. Okay, so we got a horizontal shift of 2 to the what? Left. And a vertical shift of 1 what? So sketch it. And we know it's going to look like a what? Not a half volcano, but a volcano, because it's a squared function.
Right.
And hopefully you feel good about yourself. So positive 2 means left 2 to the left. There's our vertical shift, our vertical asymptote. And we've got a negative 1 vertical. So instead, and I'm going to draw my parent graph in here. Here's my parent graph. I'm going to draw, there's the parent graph. I'm going to draw the new graph in blue. And it's going to look like that. So there's your new graph. And now, I love that shirt. I'm going to have to get that shirt for my son and my daughter. SpongeBob characters.
Isn't it your son's
Where'd you-
birthday Friday?
Yeah, how'd you remember that?
I think it was in the handouts.
No, it's not. Was it? Did you actually read them? Wow, what a concept. Yep, I got to go get him a birthday present. I got to order it off Amazon. He wants a gaming chair. I'm trying.
Is it Pikachu?
I think he's retarded. Anyway, tell him my son, okay? That's my son. I can call him what I want to. I don't care if it offends you or not. I'm talking about my son.
What kind of gaming chair?
I don't know.
You can tell us.
Does it look like a...
Yeah, is it $3.99?
You think I would pay $399 for a chair for my son to play a video game? You
Well-
think I would do that?
Well, no, but.
That would be a hail to the no.
Okay.
I'll take $299 of it and put it in the bank account and give him a $100 chair maybe. Ain't no freaking way I'd pay that much for a gaming chair. Freaking sit on a 5-gallon bucket and play the daggum game. You don't need to sit in there for 3 or 4 hours to play a freaking game. Then you'll grow up and be in somebody's basement doing nothing. Anyway, that's it. Look at there. Let me erase mine, because mine looks like crap. Ooh, mine even had, they even used the blue. Look at there. Looks just like that. So what's our domain? Negative infinity to what? -2, and then from -2 to what?
Infinity.
Infinity. Good job. You got somebody speaking out there.
Settle down, Pendleton.
All right, yeah, settle down, Pendleton. All right, now what is our range? Negative infinity to what? I'm sorry. I'm thinking of.
-1 to.
Thank you. -1 to infinity. And that should be your domain and range.
-1 not included.
Yeah, exclusive. Oh, Lord. Might as well quit. There's the function right there.
I give up.
Now,
crap.
here's what is the degree of each function? X squared. All right. So what is 2x squared divided by x squared? 2. That is your vertical what? Your horizontal what? Asymptote. Now, find your vertical asymptote. Vertical asymptote is No sneezing in class, please.
Yeah.
Okay, x squared, here's your vertical asymptote. X squared minus 1 minus 4 is equal to 0. X squared is equal to 4. X is equal to positive or negative what?
2.
So that's your vertical asymptotes. Now, how do I know what to draw this as? Well, first of all, you've got to find your horizontal asymptotes. So your horizontal asymptotes, and this is what you're going to be taught later, there's 3 tests. This is the first one. 2x squared over x squared. Let's highlight, take your highlighter and your notes, and highlight I hit the little, just hold on. Highlight those 2 right there. You have the same degree. If the degree of the denominator is the same as the degree of the numerator, then you take the coefficient of both, which is 2 over 1, which is 2. So that is your horizontal. So you know that you draw a horizontal asymptote there, a vertical asymptote here. Above always looks like a volcano. Now, what does a x squared function look like? It looks like a parabola, and it will go in the middle on the bottom. Now, how do you know that? You just know it, or you will do it on your calculator. The main thing on this problem is that you can find your vertical and horizontal asymptotes. To sketch it, you would use predominantly your calculator. Capiche? So that is a test question, but you can't do this one without your calculator unless you're Rain Man and you know what it looks like and you've memorized it.
Never seen that movie.
It's a good movie. It's one of those movies I can just watch one time. After that, I don't care nothing about watching it again. You know, you got movies that you can watch over and over and over, and then you got movies you can only watch one time. That's one of those movies I've only seen it one time, and I haven't seen it since. It's a good movie. Yeah, Sixth Sense, I can only watch it at one time.
I know.
Because it's stupid.
Well, maybe twice, because then you can kind of like realize everything. Like
I remember the good part about that movie is at the end when you go, oh man, Bruce Willis is dead. Because you don't realize that he was dead during the whole movie.
Yeah.
Okay.
Yeah. I was so surprised.
Yep.
Got no idea what y'all.
Okay, well, that's because you don't watch any movies. You probably only watch those movies that have computer graphics out
Yeah,
the
like
rear
the
end.
SpongeBob movie.
And no storyline whatsoever. All right, that's what they're telling you here. I'm not going to go through all of that. We've already done it.
End of slideshow.
All right, let's go to the next one. You only got 2 things in there. What's the first thing? 1 over x. And the second one is 1 over what?
X squared.
I mean, come on. It's not that difficult.
Peter, we need to go spend 15 minutes figuring out what your quote for the day is.
Yeah.
What?
Oh yeah, we need to fix your quote for today.
Good decisions don't live in a day.
Y'all still working on it. Okay.
I like that. That's actually
Good decisions do not a ditch and box make. Okay, we got to work on that. We got to get it in there. Good decisions does not a ditch and a box you live in make. We got to put that in one little
Does
quote.
it have to be like Yoda?
the box. Just
A ditch and a box, yeah. You live by the ditch so you can get water, to survive
Yeah,
off
like,
of.
like microorganisms you can eat.
People say I'm insensitive. No, I just had a daddy and a mother that whooped my butt whenever I didn't make good decisions. So I guess I'm crazy. Isn't that what you're supposed to be after you've been you've been beat up all your life? You'd be crazy. Is that what it is?
Maybe.
Yeah. I think I'm crazy. That's what it is. Here we go. We've already talked about vertical and horizontal asymptotes. I'm not going to go through that. Okay, here we go. Find the domain and the asymptotes. Well, first of all, you got to set the denominator equal to what?
0.
We know this is a 1 over x squared, so it's a full volcano type deal. We don't know what it looks like, so go ahead and do it on a calculator to see what it looks like. But I'm going to set the denominator, and my whiteboard went away all of a sudden. I don't know why. hold on. Let me go back and get my whiteboard. It just disappeared. I guess when you get out of the whiteboard, it kind of, get out of one publisher, it kind of knocks you out of the other one. There we go. Okay. So first of all, I'm going to set the denominator equal to 0, Hubert. Thank you, class. That pause meant I wanted you to interact with me.
0.
Forget it. 2x squared plus 5x minus 3 is equal to 0. 2x squared plus 5x plus blank is equal to 3 plus blank. 2x squared plus 5 halves x, plus blank is equal to 3 plus 2 times blank. And you know you can skip some steps on here. I'm not skipping too many steps, but there's about 2 or 3 steps you can skip here. Like this step you could do 5 halves in your head, and then you could say 5 halves times 1 half is 5/4, so that'd be 25/16. You can do all that in your head. You should be able to after as much completing the square as I've made you do. 2x plus 5/4 quantity squared is equal to, that'll cancel that to an 1/8, and I'm going to make that 24/8 plus 25/8. Y'all check me on that.
Yeah.
Is that 49? Oh, perfect square. Good stuff. 2 times x plus 5/4 is equal to 49/8. I'm not worried about the vertex right now because you're not doing the whole function. So the vertex of the denominator does not help you too much. You just want the x what?
Intercept.
You want the vertical asymptotes, yes. So divide by 2, you get 49/16. X plus 5/4 is equal to 49/16 is positive or negative what? 7/4. And then bring that 5 over, it'd be a negative 5. So what's 7 minus 5? 1/2. That's one vertical asymptote. And then plus, minus 7 minus 5, what is that?
12. So
And that's negative 3. So we know we've got vertical asymptotes at 1/2 negative 3.
Okay.
Now, this is x to the first, and this is x squared. Now, there's going to be a test here. I think this is where they actually get the test. You can't divide x squared into x to the first, can you? So, they're going to have to be, probably going to be 0, but we're going to, because there's a test here, and I'm thinking they're going to introduce the test here. So, let's go ahead and see what they did. Vertical asymptote set denominator equal to 0. They got 1/2 and negative what? 3. The equation of the asymptotes, okay, we know that. We know that. They should, okay. They're wanting you to do it the old way. How did I know that the y is equal to 0? Because they're going to give you a test. If the degree of the denominator is greater than the degree of the numerator, write that down. This is in red. If the degree of the numerator, or denominator, is greater than the degree of the numerator, your horizontal asymptote is going to be y is equal to 0. Now they're going to give you that test later. How do you find it without the test? This is you divide everything by this guy right here. That's the highest what? Degree. It's the leading term. It's the highest term. It's the leading degree. So you divide everything by x squared. And that gives you this. Okay? And what they're saying is, as the x gets larger, let's say 100. 1 over 100, 1 over 1,000, or 10,000, whatever the case may be. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, yeah. Over 2 plus 5 over 100 minus 3 over, what's 100 squared? 10,000? All right, what's this going to? What's 1 over 10,000 and 3 over 10,000? What is that? In algebra, you need to get used to saying that. I mean, in calculus. What's 1 over 10,000? What's very small in math? 0. This goes to 0. This goes to 0. 5 over 100 is point what? 0.05. This is 1 over 100, 0.01. So I'm just going to put 0.01 over 2 plus 0.05, 2 plus 0.05, and this is going to give you what? Take 0.01 and divide by 2.05 on your calculator. What do you get? I can't hear that. I heard
0.004.
0.004, 2 zeros?
Yes.
Basically, it goes to what? It goes to 0. This is what limits is right here. I just went through and done a limit for you. Okay? That when you get big numbers, in the denominator, what does it go to?
0.
It goes to 0. So then you're left with just this, and that goes to what? 0. So the bigger the numbers, the more you go to what? 0. So that's where they're going to. But you can say when the degree of the denominator is higher than the degree of the numerator, your horizontal asymptote will go to 0. Here's what the function looks like. You would not know that. So make sure you know how to graph it on your calculator. Algebraically, what am I asking you to find? The vertical and the what? Horizontal asymptotes. All right, try that one. This one, the degree is the same. All I want you to find is the vertical and horizontal asymptotes. Yes, question.
He was stretching.
Okay, so this one, the degree, oops, it's supposed to be red. The degree of the numerator is equal to the degree of the what? So therefore, you just use the coefficients. In this case, it's 2 over what? 1, which is 2. And what's our vertical asymptote?
3.
So now you've got your vertical asymptote and your horizontal asymptote.
Yay.
And I guarantee you somebody in here went through algebra class and couldn't do vertical and horizontal asymptotes. But you don't have to raise your hand or anything. Did they do the horizontal? There's the horizontal. Divide each term by x. Again, are they doing it the long drawn out way? Yes. They're doing it the long drawn out way so you will appreciate the rules they're going to give you here in a few minutes. All right, do that one. This one you have to divide. Why? Because the degree of the numerator is higher than the degree of the denominator. I'll do the vertical asymptote for you. It's going to be 2.
No way.
Yeah. So now I'm going to take x minus 2 and I'm going to do x squared plus 1. We got a term missing, don't we?
Uh-oh.
So x minus 2 into x squared plus 0x plus 1. So if I have x squared, if I have the degree of the denominator is higher than the degree of the numerator, then I'm going to what? Divide. Is it already 10-minute class over?
Just a bit.
X will go into x squared. X times x is x squared. X times -2 is -2x. You always subtract. That'll make that a plus. Bring down to 1 to help out. How many times will x minus x go into 2x? 2 times. 2 times x is 2x. 2 times -2 is -4. We don't care about the remainder. We don't care about that. This is what we call an oblique asymptote. I don't know if they're telling you that in this slide. This is called an oblique. Why? Because it's going at a 45-degree angle. Because what is your coefficient? 1 over what? 1. So it's going at a 45-degree angle. So in this case, we got a horizontal asymptote. What's the vertical shift? 2. And we've got a vertical asymptote of what? 2. So this function is going to look something like this, probably. But you need to be able to find it. And what we're going leading to, well, what time is it? It's class over 10. All right, let me show you where we're going with this. Let me show you. There. See, there's the drawing. See, I just showed you. Now, there we go. Here's the test we're leading up to. Vertical asymptotes, other asymptotes. It's telling you to divide, to take the coefficient, and so on. We'll take off from there. You should be able to work on 5.1 and a little bit of 5.2. Y'all get out of here.
Sir, Hubert.
Hold on. Let me stop.